Let us look at example 1 of 1.1, page 7 of our lecture notes. In this question, you have a gas in a tube in which an external electric field is being applied to it, and this results in both negative and positive particles flowing in the tube. The negative particles flow in one way, and the positive particles flow in opposite direction. So the first part of the question, you are asked to find the current that's due to the flow of positive charges. To do this part of the question, we simply have to consider the charges flowing through at any one point per unit time. And here, since we are considering the flow of positive charges, so we'll just consider the charge contributed by the positive charge. So at any one time, the charge is given by the number of charges multiplied by the charge on each particle, which is given in the question by 2e. So the number of positive charges as given in the question is 1.56 times 10 to the power of 15. Each of this carries a charge of 2e, so it's 2 times 1.60 times 10 to the power of minus 19. And all this is being done in 1 second. So we will have 4.99 times 10 to the power of minus 4. The unit for current is A. So that's the first part of our question. In the second part of the question, you are asked to find the current now due to the flow of negative charges. So as before, we consider the current that's only due to the charges, the negative charges, and then so it's the charge divided by the time. So therefore it's the number of negative particles that flows through multiplied by the charge on each negative particle, which is E. We're looking for magnitude here, so I'm going to draw the negative sign. So that will work out to be 1.56 times 10 to the power of 15 times 1.60 times 10 to the power minus 19, and the whole time we are considering is the amount of charge that flows through is actually 1 second. And so that is 2.50 times 10 to the power minus 4 ampere. Lastly, we are asked to find the net current that's through the gas. Now the current through the gas, there are two contributions. One is contributed by the positive charges and one is contributed by the negative charges. To decide whether we need to add or subtract the two currents, we need to look at the direction of the current contributed by each of the type of charges. So looking at the diagram, we can see that for the positive charges, it's flowing towards the right, and so it contributes a positive current, okay, towards the right. Now, for the electrons, or for the negative charges, okay, it's flowing to the left. But by convention, the current is actually in opposite direction to that of the flow of negative charges. So it also contributes a current to the right. So in all, the two currents actually are pointing towards the same direction. Hence, we should add them together, and therefore, the net current must be the current due to the positive charges plus the current due to the negative charges, and we will have 4.99 times 10 to the power of minus 4 plus 2.50 times 10 to the power of minus 4, and that works out to be 7.49 times 10 to the power of minus 4, and remember to put in your units in amperes. So that's the answer.